The fifth type is a jockey pulley drive. So whenever we have given here a open belt drive arrangement and the distance between the driver shaft and the driven shaft small distance, in that case the arc of contact form is smaller, and because of that the power transmission will be lower as the tension will be lower value. So whenever we have a open belt is used and distance is small, in that case we are providing here the idler pulley. This idler pulley will going to increase the angle of contact for the driver as well as the driven pulley. So in an open belt drive arrangement, if the center distance is small or if the driven pulley is too small, the arc of the belt contact with the driven pulley will be very small, which reduces the tension in the belt. As we know that T2 by T1 is same as equal to e to the power mu theta. Since the theta will be small, the tension will be also small. If the belt required the stress cannot be achieved by other method, a sluggish pulley called as a jockey is placed on the slack side of the belt as shown in the figure. So this arrangement is called as the jockey pulley drive. Number of times we require to transfer the power in which the axes are right angles to each other. In that case we can use the quarter turn belt drive. So as shown in the figure, we have driver pulley and we have driven pulley. This one is the front view, so you can visualize the pulley completely, and in the top view you will get the driven pulley here. So this one is representing the belt. This belt here is wrapped around the driver pulley as well as the driven pulley, and the angle made by the two pulley will be equal to 90 degree. So quarter turn belt drives are also known as the right angle belt drives. It is used with the shafts arranged at the right angles and rotating in a certain direction. To prevent the belt from leaving the pulley, the width of the face of the pulley must be greater than or equal to 1.4 times of B, where B is the width of the belt. If the pulley cannot be arranged or when reversible speed is desired, a quarter turn belt drive with guide pulley must be used. Sometimes the idler pulley is also used in conjunction with the two pulley, that is the driver and driven pulley. These are most commonly used in the industry for parallel power to tangential power transmission. The seventh type is the compound belt drive. In this case we have a driver pulley and the driven pulley. The distance is very large. In that case we can use here a compound pulley. The compound belt drive is used when the power is passed from one shaft to another through multiple shafts. So this one is one shaft, that is the driver shaft, then we have a compound pulley shaft, and then we have a driven pulley shaft. So these are the 7 arrangements that are used in the belt drive. We can also classify the belt drive into 3 categories, that is the light drives, medium drives and the heavy drives. The light drives, they are used in agriculture industry and small machine tools to transmit the small forces at the belt speed of about 10 meter per second. Then we have medium drive. They are used to transmit medium forces at belt speed more than 10 meter per second but up to 22 meter per second like machine tools. And the heavy drives, they are used in compressors and generators to transmit large forces at a belt speed above 22 meter per second. When you have to normally use the heavy drives, then the multiple belts are used so that the power distributed equally between the belts, and the V belts are normally preferred rather than the flat belts. There are 4 different types of belts are used. The first one is a round belt. The round belts are generally made up of a rubber. Then we have V belts, are arguably the most widely used belts in the industry, and they are normally used for high power transmission. Flat belts are also used to transmit the power from one shaft to another, but in all these belts the slippage is a main problem, and if we use the timing or the toothed belts, in that case that problem can be eliminated. The flat belt cross section is shown here. We have width is equal to B and the thickness equal to T. So this one is representing the cross section area of a flat belts. They are used to transfer the power from one shaft to another. Normally used to transfer the power if the distance between the shaft is 5 to 10 meter. But their power carrying capacity is lower. So in this case they have to use for low power. but the speed is very high in the case of flat belts. They are usually classified as a small oven endless belts or a high tensile flat belts. Oven inlet belts are particularly useful where minimal vibration is required on the driven pulley due to semi-elastic material used in the construction. High strength flat belts are often useful because they eliminate the need for high belt tension used to hold the pulleys, which in turn reduces the load on the shaft bearing. The material used for the high strength flat belts is a viscous resistance abrasive compound. But the problem with the flat belt is that they are not suited for the application where the center distance between the pulleys is small. In that case, we have to use the V belts, which replaces the flat belt. In fact, the V belts are the most common belt type used today. A V belt has a trapezoidal, that is a V-shaped cross section that fits into a similar groove on the pulley, and it has a certain sheave also. As the V-belt drives has a larger contact area, this surface is in contact with the pulley as well as the side is also get contact with the pulley, and therefore the friction force will going to increase because of a larger contact area. It has a one bottom and two sides, so they can transmit greater power for the same dimensions. They are very familiar in the machine tools such as the lathes, drills, milling machine and the power tools, and they are also widely used in the non-industrial applications. V-belts are mostly used in the factory's workshop where a large amount of power has to be transmitted from one pulley to another, and when the two pulleys are very close to each other. Normally preferred if the shaft distance is less than 2 meters and for large amount of power and moderate speed. The round belt has a circular in cross section and normally used in a pulley with a 60-degree V groove. So the include angle between the groove is equal to approximately 60 degree is used. This type of round belts are normally suitable for idler pulleys that guide the blade or when O-ring type belts are used. So they are normally preferred in the case of idler pulleys. The advantage of using the round belt is a smaller initial tension. Almost there is a negligible vibration and noise, and they are suitable for a distance greater than 5 meters. And finally we have the timing or the toothed belts. The flat belt V belt are the excellent at transferring the motion. They have some limitations also. For example, the belt sleeve cannot be eliminated in either in the flat belt and the V belt. Some application does not require any type of slip. In that case we have to use the timing belts. A toothed belt is a positive transfer belt that does not need friction for power transfer. It transfers the force via teeth similar to chain or a gear drive, but with much lower noise levels and without the need for excessive lubrications. So noise problem is less as compared to the gear, and the vibration problem is also less as compared to gears. These types of belts have a teeth on the engaging side of the belt. These tooth fit to the corresponding grooves. You will find here there are the grooves machined onto the pulley. A toothed belts do not slip at all and are used in the application where maintaining accurate timing and the position is critical. As a result, these belts are also known as the timing belts or the synchronous belts. They are commonly used in automobile and motorcycles engines to power and the time camshafts. Timing belts are a positive transfer belt and can track the relative movement. These belts have teeth, so where the precise and the reliable transfer is required, we have to use the timing or the toothed belts. The selection of a belt drive. So certain parameters you must consider before go for the belt drive. The very first is that the speed of a driving and the driven shaft. Second, what speed reduction ratio you require, how much power is to be transmitted, what is the distance between the two shafts, the positive drive requirement, shaft layout, location available and the service terms. Depending upon this, you have to select the belt drive. We have just seen here how to select the belt drive. The flat belts are normally selected if the shaft distance is 5 to 10 meters for low power and the high speed. V-belt are very commonly used in the industry for large amount of power, but the shaft distance should be less than 2 meter and used for normally for moderate speed. Round belts are used as the idlers for distance greater than 5 meter. And if you do not want any type of sleeve, then you can think of the timing belt where the precise and the reliable transfer of power is required. The materials used for the belt is the leather belt, cotton belt or fabric belts, rubber belts, balta belts and the plastic belts. Plastic include the polyester, polyvinyl chloride, silicone and polyethylene. The most important material for a flat belt is a leather. The best leather belts are made from the strips of 1.2 meter to 1.5 meter long, cut from either side of a backbone of the top grade step heights. The side of the leather hair is smooth and hard on the flesh side, but the flesh side is strong. The fibers on their head side are perpendicular to the surface, while the flesh side parts are interconnected and parallel to the surface. Cotton belts or fabric belts. Most fabric belts are made by folding 3 or more layers of canvas or cotton duck and stitching them together. These belts are also woven into a strip of desired width and thickness. They are applied like linseed oil with some filler to make the belt waterproof and prevent injury to the fibers. Cotton bands are inexpensive and suitable in the moist climates and the moist environments. Since the cotton belt required little attention, the belts are mostly used in the farm machinery and the belt conveyors. The rubber belts are made of a layer of a fabric that are fastened with a rubber structure and have thin layer of rubber on the face. These belts are very flexible but are quickly destroyed when allowed to come in contact with the heat, oil or grease. One principal advantage of these belts is that they can be made endlessly easily. These belts are found suitable for sawmills, paper mills where they are exposed to the moisture. And balta belts. These belts are similar to the rubber belts except that balta glue is used in place of rubber. These belts are acid proof and waterproof and are not affected by animal oils or alkalis. The belt should not be used at a temperature above 40 degrees because at this temperature the sanding starts to soften and become sticky. Balta belts have a strength of 25% higher as compared to the rubber belts.